Hey everyone, so this is Alex here from MathSoc, and we're presenting a series of problems for you guys today on 2931 to help you guys better prepare for your exam. So I'm going to present question 4 today, okay? And question 4 is a chi-squared V distribution, okay, and a normal distribution, and we want to show that the combination of y over the square root of x over v is t distributed. Okay, so let's jump into the distribution of each of these random variables. So what we are interested in is what chi-square v looks like, what normal looks like, and what t looks like. Okay, so let's have a look. So this is from your lecture textbook. Okay, so it's on page 77. There's a normal, there's a distribution table, and it pretty much has everything. So normal distribution is, as you remember, is this, right? T distribution is a little bit special. It's this gamma over gamma, and that's 1 plus x squared, whatever. And you also have the chi-square distribution, which is n over 2, 1 over 2 gamma distribution. So I'm just going to quickly write that down onto our notes over here. So first up, we have our chi-square distribution, which is a gamma 1/2, v over 2 and 1/2. So copying it from the lecture notes, you should get something like this. And for normal distribution, you have a standard normal, so it should look something like this. And for t distribution, let's say ft of t, it is flipping back to our lecture notes, it's gamma plus 1 over 2 over square root of v times pi gamma of v over 2 times 1 plus t squared over v to the power of negative v plus 1 over 2. Alright, just like that. Okay, cool. So, now, we want to show that y over square root of x over v is actually t distributed v random, v degrees of freedom. So what we need to do first is to use a technique called bivariate transform, which basically means we're going to take an xy, two variables, and then change it to u and w, where u is some function of xy and w is some function of xy. So in this case, we want to really pretty much get u to be exactly what the question asks us to, which is y over square root of x over v, and w to equal to x. And then it's also helpful, so, and then after this, we will apply the bivariate transform formula, which is something like this. Okay, so f is basically f, the PDF of u and w is PDF of x and y times the Jacobian of the absolute value of the Jacobian xy over u w. So okay, so now with this as the yeah, with this as the formula, we can get straight into finding the Jacobian. Okay, so if you remember correctly, Jacobian is a matrix. All right, in this case, if we're using xy over uw, it's a matrix of dx du on the far left, dx dw on the next line, and then dy du, dy dw. Okay, and then so we wanted to find the determinant. Yeah, we actually wanted to find the determinant of this guy and taking the absolute value of that. So in order to do that, we need to make x and y the subject. So just quickly over here, x and y, okay, making x the subject is easy. We just need to make x equals to w, and making y the subject, you actually get y equals to u times square root of x over v, which is u times the square root of w over v. So dx du is, okay, so first of all, what is the what's the determinant of this Jacobian? It's dx du times dy dw minus dx dw times dy du, right? So dx du is 0. So we just straight up cross out everything on this one, minus dx dw, which is 1, times dy du, which is square root of w over v. So taking the absolute of that, and we have our Jacobian. Then we're going to look at the joint density of x and y, which is the product of the two marginals because they are independent. So fx comma y, x comma y is just fx comma x, fy y, and then chucking your chi-square distribution here. And now our next step, okay, is to plug the whole thing, or actually, yeah, plug the whole thing into the formula for for u and w. But we're also going to replace these x and y's. So first of all, let's write the formula again. Okay, which is like this. Yeah, so replacing x and y with in terms of u and w, what you get is over here, all your x's becomes w, all your y's or y squares becomes e to the becomes u squared w over v. So factorizing your w's out, okay, so factorizing, like grouping like terms. Oh, sorry, there's also one more term, which is the the absolute value of the determinant, which is square root of w over v. Okay, so grouping the like terms together, which is the w's. Okay, so this e to the minus half w, you'll get 1 plus u squared over v. And then you also have w grouped up together, this 1 to the power of 1 half. Oops, sorry, undo that. Yeah, so you have this 1 half and this w, I'm going to group that together. So you have v over 2 minus 1 half. Also, you have the 1 half to the power of v plus a half, v on 2 plus a half, divided by the gamma of v over 2 times the square root of pi times v. Okay, cool. So now what we're going to do now is to find, after we find the joint density, we just need to find the marginal. Because this u, if you remember, is exactly what the question had asked for. So if we can find the distribution of this and show that this is t distributed, okay, with v degrees of freedom, then we're done. So let's find the marginal of u. So to find that, we also need to specify what is the domain of w. So w over here is actually the same distribution as x. Okay, so same domain as x because x equals w. So since x is chi squared, w is chi squared. It's greater than 0. Okay, since x is greater than 0. And also looking at y, so let's write x is greater than 0. Okay, and that means w is greater than 0. And since y is just any real number, u, which is a function of y is a function of u, they're both just unrestricted real numbers. So writing it over here be a good idea. Okay, so now your w is greater than 0, so my bounds is just 0 to infinity of all this stuff with respect to w. So here at this point, we're going to factorize out all the unnecessary stuff. Okay, so v plus a half, v on 2 plus a half, we have the square root pi v, you have the gamma of v over 2, and then you're left with the integral from 0 to infinity, w to the v minus 1 over 2, e to the minus w on 2, 1 plus u squared over v dw. So now let alpha equals 2, sorry. So this function over here is actually part of a gamma distribution. And I can show you that by letting alpha minus 1 equal to v minus a half, which means alpha is v plus a half, and beta equals to minus a half 1 plus u squared over v. Sorry, a half times 1 plus u squared over v. And so this turns into a half to the v plus 1 over 2 over root pi v gamma of v over 2 integral from 0 to infinity w to the alpha minus 1 e to the negative beta w dw. And if you remember, a gamma distribution is just, okay, if w follows a gamma with alpha beta, then this is just beta to the alpha, right? Gamma of alpha times w to the alpha minus 1 e to the minus beta w, where w is positive. So that's the distribution of gamma, and if we integrate this from 0 to infinity, we actually get 1. Definition of distribution. So if we plug that into this formula over here, now we can make f u of u equals to or this expression on the left times gamma of v over 2, and then you times by gamma of alpha beta to the alpha, and make this integral just like the one over here. Okay, so then this turns into 1, and so you just end up with a half to the power of b plus 1 over 2 divided by square root of pi times v gamma of v over 2, and then alpha is v plus a half, and beta is 1/2 times 1 plus mu squared over v. Each of these to the power of v plus a half, v plus 1 over 2, v plus 1 over 2. And we can see that these two cancel out. And finally, this gives us the distribution of t. And therefore, okay, so finally this looks just like the t distribution over here, right? And therefore we can conclude that U is t distributed with v degrees of freedom, and so y divided by square root of x over v is also t distributed with v degrees of freedom. So just to recap, bivariate transform just really have 5 steps that we need to follow. So first, we need to define u and w in terms of x and y. Then we want to find the absolute value of the determinant of the Jacobian. And finally, and then the next step, finding the joint of the f of u and w in terms of x and y. And then convert this x and y, each of the x and y variables into u and w, and then finally integrating with respect to w to find the marginal distribution of u. And so that concludes the question 4. Yeah, thank you for listening, and hope you guys have a wonderful exam prep.